defining DevOps. Again, the interesting thing is there isn't any one standard definition of DevOps. You're going to find, if you look on Wikipedia, you'll find a definition. If you go to pretty much any DevOps book, you'll find different definitions. It's kind of deliberately left open a little bit because DevOps itself is an evolving idea. It's really defined by the collective body of knowledge at any point in time. But there are certainly some common elements associated with DevOps. It's kind of a diagrammatic way of saying pretty much the same thing. If you have a value stream is everything from, ideation all the way to operations. And you're not only looking at technologies, but people aspects, culture, and so on, processes for automation. Some are maybe not be automated, and technology. So there's many different processes, technologies, and people interactions happening throughout that whole value stream. Actually, something I defined long ago, back in 2019, in my book I published called The 9 Pillars of Continuous Practices. So the specific practices that affect the way leadership is done, culture, design, practices for applications, continuous integration, continuous testing, continuous delivery, elastic infrastructure, continuous monitoring, and continuous security. So unless you have a good balance of all of these different kinds of practices, you probably don't have the most effective DevOps yet. Another way of diagramming things, if you think about, again, the value stream, at the front end, you've got continuous design and development, primarily based on Agile. Identify an opportunity, understand the outcomes, evaluate possible solutions, build one or two, test it, and deploy and measure, and then continue the cycle until you're happy. Whereas DevOps is sort of in the middle about delivering what you're building. So CI/CD, continuous testing, monitoring, infrastructure, security. So the DevOps is generally represented as an infinite loop of activities that couple engineering or dev to ops. One thing to point out is, DevOps, even though it has ops in the name, does not prescribe any activities within ops, right? It's really dev to ops, not dev and ops in that sense. SRE, on the other hand, is more about what happens in ops through things like identifying site service level objectives, how you measure what's important from an operations point of view, reducing toil in non-value added work through automation, integrating with DevOps deployment strategies, monitoring deliveries, and tracking and dealing with different kinds of customer concerns, events, on-call, claims, postmortems, and so on. So together, these frameworks work together in order to provide a very efficient series of activities for design, development, delivery, deployment, and operations and maintenance. Continuous service management requires alignment of people, process, and technology. So it's always a constant balance. These things are constantly changing. And so keeping up with every aspect and making sure you got a constant balance is a little tricky. But this is, the role. There is no one universal framework. There probably won't be anytime soon, I wouldn't think. There have been attempts to do that, but generally haven't worked out very well. So being aware of these different frameworks, I think, is important for you. This is kind of a repeat of some of the goals. There's a really good book, the Accelerate book by Nicole Forsgren. She's like a data scientist, and she's done a lot of studies on DevOps performance related to team performance. And the DORA, the DevOps Research Association, she was the founder of that, I think. She's also the one that started the publication of the State of DevOps reports that are now published not only by DORA, but Puppet and other organizations as well every year. They really focus on 4 primary, what they call DORA metrics, which is the speed of, the deployment frequency, lead time for changes from code check-in to production, mean time to restore services when there's a problem, the change failure rate, how often you have failures in production, and a 5th one that was added recently on reliability, which is kind of tied in with the SRE metrics as well. So the deployment frequency and lead time for changes look at team velocity, There's strong indicators for how good the team is at delivering software. Mean time to recovery, change, failure rate, and reliability focus more on quality and stability. Together, these measures the stability of your production environment and quality of your processes in the software delivery cycle. So these metrics are really considered to be the, the fundamental foundational metrics. Certainly, when you look at measurements, there's so many possible things to measure. But when you're looking at DevOps, you should at least have measures for these because they've been proven to be fundamental and indicators of how well your DevOps is performing. There are five underlying values that DevOps based on. The acronym is CALMS. It stands for culture, establishing a shared responsibility for development and operations, promoting collaborative work environment. So that's just not just a statement. This is the idea that if, hey, let's say you're trying to deliver a product or feature, and somebody in the team is falling behind, you don't just sit there and watch and say, well, I'll wait. You try to collaboratively work with them and help them. Automation is about emphasizing automating repetitive tasks. It could be builds, could be testing, could be deployments, various things. In general, to increase efficiency, reliability, scalability. Lean is the idea of lean manufacturing concepts built into DevOps, focusing on optimizing processes, reducing waste, improving the flow of work to make it more smooth, with the cadence across the value stream to be consistent and match. There's no point in having lots of new features if you can't deploy them, for example, or lots of deployed features that ops can't handle. So having a consistent flow of work is critical. Measurement is more than just metrics, but certainly can include metrics, looking at various kinds of monitoring data, making decisions based on data, in general, with a targeted purpose to enhance performance and quality. And finally, sharing is promoting open communication, knowledge sharing. This is proactive, not just after the fact. Collaboration across teams that help not only, deliver, but improve innovation and overall improvement. So together, these values create a holistic approach, driving high performance, agility, resilience, and software development and operations, ultimately leading to better business outcomes. A lot of people think DevOps is just tools, and and I think I understand why there are many tools involved, so it can get almost overwhelming. These are just a partial list. There are literally hundreds and hundreds of tools, even in each category. So layers of tools and tool chains are necessary to help with agility, consistency, speed, and reliability. So, for example, communication and management tools, things like Atlassian, JFrog, Microsoft, Git, ChatOps, Confluence. These are good ways to help with communication. There are many others, Splunk and so on. Process automation, things like the different programming languages. ChatGPT can help now with, generative AI to create automation scripts. Value stream management products like Plutora. Automation tool frameworks, so things like TeamCity or Microsoft Azure. Jenkins is the most popular and kind of the original CI automation platform for GitHub, GitLab, very popular. Azure DevOps, very popular. CA technologies, many others. Things like Harness probably should be on the list now. Automation tools, Cucumber for automating testing, Selenium, automating monitoring, things like New Relic, Splunk. I think New Relic's now part of Data.io. Sauce Labs, App Dynamics is an application performance monitoring tool. Dynatrace, similarly, Datadog. SonarQube for scanning code. And infrastructure automation, of course, the cloud service providers and their services. So Amazon, Google, Azure, and Docker for containers, Chef for configuration management of software, Rancher, Puppet, Kubernetes for cluster management and container management, Ansible for automation of, again, containers and other things.